Good evening, dear students. Today our topic is buffer system. Buffer system, acid base and buffer system, and the importance of pH scale in biology. For example, this is pH scale, and we check the pH of gastric acid pH 1, lemon juice pH 2, orange juice 3, tomato juice 4, black coffee 5, urine 6, distilled water 7, sea water 8, baking soda 9, milk of magnesia 10, ammonia solution 11, soapy water 12, and bleach 13. This is the pH scale in biology. Chemical bonding and electron balance. Electrons in an atom are located at different energy levels. Electron is in the highest energy levels are called valence electron. Number of valence electron governs an atom's bonding behavior. Atoms are much more stable or less reactive with a full valence shell. By moving electrons, the two atoms becomes linked. This is known as chemical bonding. The stability can be achieved one two ways: ionic bond and covalent bond. First one is ionic bond. Involves transfers of electrons between two atoms found mainly in organic compounds. Sodium atoms, chlorine atoms, sodium ion cation and chlorine ion and anion. Ion an atom or a group of atoms which have lost or gained one or more electrons, making them negatively or positive charge. Ionic compounds are made up of oppositely charged ions. Ionic bonds are atoms held together by attraction between the positive and a negative ion. Compound is a neutral overall but still charge on the inside makes solid crystals. Acids and base. An acid is an ionic compound that releases hydrogen ion in solution. Acid water जो hydrogen ion in solution. A base is an ionic compound that releases hydroxide in solution. Water base, and then result is water and hydroxide solution. Another important characteristics of water can form acids and base. Dissociation of water. H2O when it splits H plus OH. Neutral water has equal amount of H and OH. Acid excess of H plus in aqueous solution. Bases excess of OH in aqueous solution. Acid and bases neutralize each other. Measurement of acidity and alkalinity pH. Acidity of a solution is greater than measured by concentration of hydrogen ion. pH range 0 very acidic to 14 very basic. Change in just 1 unit of scale, 10-fold change in H plus concentration. If concentration of H plus is equal to OH is neutral. If the pH range is less than 7, it is acidic. If greater than 7, it's basic. pH scale in logarithm. Change in just 1 unit of scale, 10-fold change in H plus concentration. More examples of pH from daily life. For example, liquid drain cleaner pH is equal to 14. Bleach oven cleaner pH is equal to 13.5. Ammonia solution pH is equal to 10.5 to 11.5. Baking soda pH is equal to 9.5. Seawater pH is equal to 8. Blood pH is 7.4. Milk, urine and saliva pH 6.3 to 6.6. Black coffee pH 5. Grapefruit juice, soda, tomato juice pH is equal to 2.5 to 3.5. Lemon juice, vinegar pH 2. Battery acid, hydrochloric acid pH 0. Ion acid. An acid is an ionic compound that releases hydrogen ions in solution. Weak acids have a sour taste. Strong acids are highly corrosive, so don't go around the state testing acids. Ascorbic acid C6 H8O6 vitamin C. Citric acid C6H8O7 are weak organic acids in citrus fruits. Phosphoric acids H3PO4 in this stuff is also used to remove rust. Strong acids completely dissociate in water. Add acid to water. For example, HCl add acid to in water H plus chlorine. Weak acids do not completely dissociate in water. Ion bases. A base is an anionic compound that releases hydroxyl ions OH in solution. Bases are also called alkaline substances. Some general properties of bases include taste. Bitter taste opposed to sour taste of acids and sweetness of aldehydes and ketones. Touch slimy or soapy feel on fingers. Reactivity strong bases are caustic on organic matter react violently with acidic substance. Sodium hydroxide or caustic soda used in oven cleaner. Magnesium hydroxide, also known as milk of magnesia, a weak base used in antacids and laxatives. Acid-base balance in biology. pH balance is important to homeostasis of organisms. Homeostasis tendency of the body to maintain a balanced internal environment even when faced with external changes such as the body ability to maintain an internal temperature around 98.6 degrees Fahrenheit, whatever the temperature outside. Examples: digestion needs acidic environment pH 2 to 3. Urine is slightly acidic. Blood must stay in neutral range near 7.35 to 7.45. Iron and salt. Compounds that dissociate in water and produce cations other than H plus and anions other than OH are called salt. The most familiar salt is sodium chloride, the principal components of common table salt. Other examples of salt: baking soda, NaHCO3, Epsom salt, MgSO4. Salts: the role of buffers. Certain salts called buffers can combine with excess hydrogen or hydroxide ions, produce substances less acidic or alkaline, act like a chemical sponge to soak up excess acid or base, keep pH constant. Buffers can be used up. Once used up, no longer help to regulate pH. Buffers are vital to maintaining pH in organisms. Example: antacids are buffers made up of salt, calcium carbonate. Bicarbonate buffer system is important in maintaining proper blood pH. Interactive animated lessons on acids and base and buffers. Acid water dissociates in water. Base water OH water. Now I will tell you about phosphate buffer system. There is no include in this slide. Phosphate buffer system. Phosphate buffer system is not important as an extracellular fluid buffer. It plays a major role in buffering renal tubular fluid and intracellular fluids. The main elements of the phosphate buffer system are H2PO4 and HPO4. When a strong acid such as HCl is added to a mixture of these two substances, the hydrogen accepted by base HPO4 and converted to H2PO4. The results of this reaction is that the strong acid HCl is replaced by an additional amount of weak acids NaH2PO4 and the decrease in pH minimized. When a strong base such as NaOH is added to buffer system, the OH is buffered by the H2PO4 to form additional amount of HPO4 plus H2O. The phosphate buffer system is also important in buffering intracellular fluid because the concentration of phosphate in this fluid is many times that the extracellular fluid. Also, the pH of intracellular fluid is lower than that of extracellular fluid and therefore is usually closer to the pK of phosphate buffer system compared with extracellular fluid. This is all about buffer system. Thank you.